everyone, in today's video we are going to cover section 3.4 beyond CPCTC. After studying this section, you'll be able to identify medians of triangles, identify altitudes of triangles, understand why auxiliary lines are used in some proofs, and write proofs involving steps beyond CPCTC. Looking first at medians of triangles, in our figure to the right, three medians are shown. Line segment AD is a median of triangle ABC. Line segment EH is a median of triangle EFG, and line segment FJ is a median of triangle EGF. Notice all three of these line segments have two things in common. They all come from the vertex, and they all split the opposite side into congruent sides. So the definition of a median is a median of a triangle is a line segment drawn from any vertex of the triangle to the midpoint of the opposite side. A median divides into two congruent segments or bisects the side to which it is drawn. Notice every triangle has three medians, so I could draw in triangle ABC a median from vertex B to the opposite side and from vertex C. As long as they would split the opposite side into congruent segments and they come from the vertex, they would be medians. In my triangle EGF, I would have one more vertex from vertex G. Now looking at altitudes of triangles, just like medians, every triangle will have three altitudes. Looking at my diagrams below, in triangle ABC, in my first diagram, I have altitude AD and altitude BE. I could have a third altitude from C that would extend to AB as long as that segment were perpendicular to segment AB. In my second diagram, I have altitude AC, altitude CD, and altitude BC. In my third diagram, I have altitude BE, altitude AD, and altitude CE. So an altitude of a triangle is a line segment drawn from any vertex of the triangle to the opposite side, extended if necessary, so like in my third diagram where I extended line segment AE, and the line segment is perpendicular to that side. So an altitude of a triangle forms right angles with one of the sides. Now looking at auxiliary lines, we'll consider the following problem. We're given that AB is congruent to AC, BD is congruent to DC, and I want to prove that angle ABD is congruent to angle ACD. Now this proof would be very easy if I had line segment AD drawn in, because then I could say that AD is congruent to itself by reflexive property, then triangle ABD is congruent to triangle ACD by side, 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 and then angle ABD is congruent to angle ACD by CPCTC. Now, this line that I drew in for line segment AD is called an auxiliary line. So we'll have a lot of proofs that involve lines, rays, or segments that don't appear in the original figure. We can draw in these lines, which we will call auxiliary lines. It's a postulate that one and only line, ray, or segment can be drawn through any two distinct points. So 2 points determine a line, or a ray, or a segment. Now, in a proof, if we were to draw in an auxiliary line, our statement would be draw line. Line can be replaced with ray or segment. Then we would name our line, ray, or segment. And then our reason would be 2 points determine a line. Moving forward, we'll look at a lot of proofs that involve steps beyond CPCTC. Now, if we consider the following problem, I'm given that line segment AD is congruent to line segment CD. Angle ADB is congruent to angle CDB. I want to prove that line segment DB is the median to line segment AC. Remember, a median is drawn from a vertex to the opposite side, and it splits that opposite side into two congruent parts. So if I were to show that line segment AB is congruent to line segment CB, then I would have DB as the median. Notice in my diagram, I have DB congruent to DB by reflexive property, which would give me my triangles congruent, and then I could state that line segment AB is congruent to line segment CB by CPCTC. Now, by first proving my triangles congruent, then using CPCTC, we can identify altitudes, angle bisectors, midpoints, and so on in order to go beyond CPCTC. Now looking at our sample problems, in my first problem, I'm given that line segment AC is congruent to line segment BC, line segment AD is congruent to line segment BD. I want to prove that ray CD bisects angle ACB. Now in order for ray CD to bisect angle ACB, I would need that angle ACD is congruent to angle BCD. I can do this by proving my triangle is congruent, then by using CPCTC to show that angle ACD is congruent to angle BCD. Notice in my diagram, I have side CD congruent to side CD because of the reflexive property, which would give me my triangles congruent by side, 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 which would show that angle ACD is congruent to angle BCD, making ray CD the bisector of angle ACB. Now listing out my statements and my reasons, I have line segment AC is congruent to line segment BC. That was a given. Line segment AD is congruent to line segment BD. Also a given. Line segment CD is congruent to line segment CD by reflexive. I have my triangles congruent by side, side, side. Then I can say that angle ACD is congruent to angle BCD by CPCTC. Now I have ray CD bisecting angle ACB by the definition of angle bisector. Now looking at problem 2, I'm given line segment CD and line segment BE are altitudes of triangle ABC, which would make these two angles right angles and these two angles right angles. Line segment AD is congruent to line segment AE. I want to prove that line segment DB, so this segment here, is congruent to line segment EC, this segment here. Notice I have line segment AD congruent to line segment AE. So if I could show that line segment AB was congruent to line segment AC, I could use the subtraction property to show that DB is congruent to EC. Segment AB is a part of the triangle ABE, so this triangle here. Segment AC is a part of triangle ACD, this triangle here. So if I can prove these triangles congruent, I can prove my segments congruent, then I can subtract my smaller segments. Looking at my diagram, to prove those triangles congruent, I have an angle and a side, so I need another angle. Well, I have reflexive property, so angle A will be congruent to angle A, which would give me my triangles congruent. Looking at my statements and my reasons, I would have line segment CD and BE are altitudes of triangle ABC. Then angle ADC and angle AEB are right angles because altitudes form right angles. Now I can say these angles are congruent because all right angles are congruent. Angle A would be congruent to angle A by reflexive property. Line segment AD is congruent to line segment AE. That's given. Now my triangles were congruent by angle side angle. My whole segment AB is congruent to my whole segment AC. Then I will subtract my smaller segments AD and AE to give me DB congruent to EC by the subtraction property. Now looking at problem 3, I'm given G is the midpoint of line segment FH, so that tells me HG is congruent to GF, EF is congruent to EH, so this segment here is congruent to this segment here. I want to prove that angle 1 is congruent to angle 2. Notice, if I show that angle EHG is congruent to angle EFG, 1 and 2 are sup to these two angles, so I could use my congruent supplements theorem. So if I can prove the triangles congruent, then I will have those angles congruent. Then I can show that angle 1 is congruent to angle 2. But notice in my diagram, I only have one triangle. But I do have a point, and if I draw from my point to the vertex, this would split my big triangle. So I can draw in segment EG. EG would then be congruent to itself. My triangles would be congruent by side, side, side. Now I could state that angle 1 is sup to angle EHG, and angle 2 is sup to angle EFG, and then angle 1 is congruent to angle 2 because they're sup to congruent angles. Now to list my statements and reasons, I'd first have G as midpoint, that's a given. FG is congruent to HG by the definition of midpoint. Then EF is congruent to EH by given. I can draw in segment EG. 2 points will determine a segment. Then that segment will be congruent to itself by reflexive property. Now my triangles are congruent by side, side, side. Now my angle EHG and angle EFG are congruent by CPCTC. Now I want that angle 2 is sup to angle EFG and angle 1 is sup to angle EHG. Because if two angles form a straight angle, assumed from diagram, they are sup. Then angle 1 is congruent to angle 2 because supplements of congruent angles are congruent. Looking at my last sample problem, I'm given that angle T is congruent to angle Y. Angle SVZ, so this angle here, is congruent to SXZ, so this angle here. Segment TV is congruent to YX, so this segment is congruent to this segment. I want to prove that SZ is the median to TY. So if I show that TZ is congruent to ZY, then I can say that SZ is a median because it comes from a vertex and it splits the opposite side into two congruent pieces. Now looking at my givens, I have an angle and a side congruent to another angle and a side of my two smaller triangles here. Then I have two angles that are outside this triangle congruent to each other, but those are sup to these two angles here. So I can prove my two smaller triangles congruent and then use CPCTC to prove that TZ is congruent to YZ. So looking at this in my statements and reasons, I would have angle T is congruent to angle Y, because that's given. Then angle SVZ is congruent to SXZ, given. Now I'll say that angle TVZ is sup to SVZ, and angle YXZ is sup to ZXS. Because if two angles form a straight angle, assume from diagram, then they're sup. Now these two angles are congruent because they're sup to congruent angles. Now my last given of TV congruent to YX. Now my triangles are congruent by angle side angle. Then TZ is congruent to YZ by CPCTC. Since these are congruent, I can say that SZ is the median to TY because the definition of triangle median. In this lesson, we learned a median of a triangle is a line segment from a vertex to the opposite side and bisects that side. An altitude of a triangle is a line segment drawn from a vertex to the opposite side and is perpendicular to that side. And an auxiliary line is a line, ray, or segment that we can draw into a diagram. As a wrap on this video, we'll see you in the next one.